Lesson 3.1, we're talking about derivatives of polynomials and exponential functions. Now, we've been talking about derivatives for a while, and we've been using this equation to find the derivative. This is the notation for the derivative. This is the limit definition of a derivative that we've been using. And physically on the graph, what it means is we're finding the slope of the tangent line. So if I want to find the slope of the curve, it changes from point to point. So depending on what point you're talking about, you draw a tangent line and you find the slope of that line, and that tells you the slope of the curve at that point. Now, this process takes a long time, as you saw in the last chapter. So now we're going to start using a shortcut for it. Before we get to the shortcut, let's look at constant functions. So a constant function is just y equals a number, and it makes a horizontal line through the graph. So just y equals c, c is standing for some constant. If we find the slope of that line, it's 0. So anytime you have a constant function, the derivative of a constant is 0. So that's just something to remember. When we looked at the limit definition, what we ended up having was the number minus the number, which ends up giving us 0. So that's how we got 0. Let's look at a linear function. So a linear function, the slope, for example, y equals x is just 1. So we don't really need the limit definition to find the slope of a line because we've already practiced that in algebra. You can just find the rise over run. For y equals x, it's just the number in front of x, which is 1. So the derivative of x is 1. Next thing. Okay, the derivative of x is 1. Here, the derivative of x squared is 2x. The derivative of x cubed is 3x squared. The derivative of x to the fourth is 4x cubed. So instead of using that long formula, we can just kind of memorize these. In fact, instead of memorizing, let's try to make a rule for this so we can figure out how to find all derivatives quickly without using the limit definition of a derivative. So take a second and see if you can pause the video and figure out what the rule would be to find derivatives by looking at these 4 examples. So this is the rule you should have come up with. If you have a variable to an exponent, you bring the exponent in front. So the n has moved in front right here. And then you take 1 away from the exponent. So that's why you have a minus 1 on top. So this is called the power rule, and this is what you need to know to find derivatives quickly without using your limit definition of a derivative. And we're going to use this in the next example. So go ahead and write these examples down and see if you can find the derivative of each one using the power rule. Go ahead, pause the video, see if you can do it, and then we'll check our answers together. So in example 1, you've got all these different notations which you're going to have to recognize on tests and the final. So if you have f prime, that means derivative, and you should have 6x to the 5th because you brought 6 in front and then took 1 away from the exponent. Y prime just means derivative of the y, and you should have 1000 in front and then 999 on top because you took 1 away. dy over dt, this is just another way of saying y prime. And what it means is the change in y divided by the change in t. And that just tells you that your output variable is the y and your input variable is the t. It's just a cooler way of writing y prime. And so you should have 4t to the 3rd. And then d over dr is just another variation of dy dt, where it wants you to find the derivative. They never gave you an output variable, but they are saying your input variable was r. They just don't give you an output variable. And so you have equals 3r squared. For problems like these, the exponents are a little more tricky. So remember, when you have a variable in the bottom, it has a negative exponent. And when you have a variable in a radical, it has a rational exponent. So you need to rewrite these with different exponents so that you can use your power rule. Let's do it together. So the first thing I would do is rewrite the inside as x to the negative first, because that has an exponent of 1, and since it's in the denominator, we can change it to a negative 1. Then we can use our power rule. We can bring negative 1 in front, then you've got your variable, then you take 1 away from your negative 1. So we subtract 1 from negative 1, we get negative 2. Since it was written as a fraction, write your answer as a fraction. So you've got -1 as your numerator. X to the -2 makes it +2 in the denominator. So that would be your answer. This is asking for the derivative with respect to x. First, change it into a rational exponent. Square root means it has an exponent of 1/2. Then you would find the derivative. So bring 1/2 in front, then take 1 away from your 1/2. So you're going to get -1/2. Since it was written as a radical, write your answer as a radical. So you've got 1/2. So 1 is the numerator, 2 is the denominator. And in the denominator, you have another rational exponent. It's negative, so it's in the bottom. So x is in the bottom. And the 1/2 means square root. So you've got 1/2 radical x.